So last lesson, we redefined what a polynomial was. We said a polynomial is several terms separated by plus or minus signs. I should be fussy. Polynomials, Brianna, can't have weird stuff in them. For example, the x can't be inside a square root or a logarithm or anything. In fact, what we really say is the exponents on the x have to be whole numbers. 0, 1, 2, 3, 4, 5, 6. No negatives. No, because a square root is technically a fractional exponent. No fractional exponents. Some terminology, we talked about degree. This is very important. You have to be able to tell at a glance the degree of a polynomial. We talked about the constant term. That was the term with no variable, -5 in this case. We talked about the leading coefficient, which I chose to abbreviate LC for the remainder of this lesson because I hate writing out the word leading coefficient. Then we said every polynomial, turn the page, of degree 0, also called a constant function, is a horizontal line. The line f of x or y equals 3, that's a line 3 high. The line f of x or y equals -1, that's a line -1 high. It's of degree 0 because there's no 0 x's. There's an x to the 0, invisible 1 there, doesn't exist. It's a horizontal line. So we said if we wanted to generalize, every constant function, we use the letter C for constant, has a horizontal line, slope of 0, domain all reals, range whatever C is, whatever its height is. It has no x-intercepts. It will always have one y-intercept because eventually it's got to hit the y-axis. It has no x-intercepts unless it's the actual x-axis, which is the equation y equals 0. Somebody could have used that on the test, by the way. Y equals 0 is the x-axis equation, and that will have an infinite number of a bunch of x-intercepts. Then we talked about degree 1, what we call linear functions, what you called in Math 10 y equals mx plus b. We said every equation of degree 1 is either a positive slope, negative slope. It has one y-intercept, one x-intercept. It's got a domain of all reals and range of all reals. If you're in any way slanty, you're eventually going to hit negative and positive infinity up, down, negative, positive infinity left, right. So in summary, we said, if you have something like this, mx plus b, slope-intercept form, degree 1, it's a line with a slope of m, domain all reals, range all reals. There's one y-intercept, one x-intercept, one of each. Y-intercept is b. The leading coefficient, if it's positive, tells you it's uphill, positive slope. If it's negative, tells you it's downhill, negative slope. And because these all form lines, we call them linear functions. Then, turn the page. We looked at our old friend, the quadratic function. What graph did you call this? Begins with the letter P. The parabola. Any degree 2, any x squared polynomial equation. Some terms you need to know that x-intercepts, the fancy word for x-intercept is the roots. That's important because that's what your graphing calculator calls them, the roots. We said what's the same for any parabola, whether it opens up or down, the domain is going to be all reals because eventually Mackenzie is going to get negative and positive infinity. We said every parabola has either a maximum or a minimum, what you call the vertex. We noticed actually our graphing calculators can find the vertex for us, but we have to tell it whether we're looking for a maximum or a minimum. But it does have a max function and a min function. The y-intercept, I just realized I'm recording and I walked away. That's not very good. Anyway, sorry to those of you on YouTube. The y-intercept, we noticed, is the constant term. In other words, Rachel, what's the constant term of this function right here? What's the y-intercept of this function right here? 10. What's the constant term of this parabola right here? You know what its y-intercept is? And you'll notice this time I scrolled up. You can't even look at the graph. It's -5, trust me. Well, now, why does that work? Well, really, here's what it's saying. To find the y-intercept, you put a 0 in for x. If you put a 0 in for the x squared, it's going to vanish. If you put a 0 in for the -4x, it's going to vanish. And all you're going to have left behind is a -5, which is your y-intercept. All parabolas open up or down. They have one turning point, which you called the vertex. It's either maximum or minimum. You learned last year, if the leading coefficient is negative, that means your parabola opened down. That means you had a maximum. The vertex was the highest point. If the leading coefficient was positive, means the parabola opens up. Means you have a minimum. Your vertex is the lowest point, the minimum point. We paused here. Ready, Mackenzie? So we're going to talk a bit more about the parabola, and then we're going to give you a bit more terminology. You want your graphing calculators out. So it says this: the graphs on the previous page show that polynomial functions of degree 2 quadratics can have 0, 1, or 2 x-intercepts. If you do a little sketch right here, you can have no x-intercepts. You can have one x-intercept where your vertex is the x-intercept and it just kisses there. Or you can have 2 x-intercepts, 2 roots. You may even have learned a way to tell that last year when you were looking at the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You might have done some talking about the discriminant. 3 of the functions can be written in factored form. This one can be written like that. Okay? You guys stay on this page. I'm going to go back. We're talking about this function. Oh, come on. We're talking about this function right here. What are the x-intercepts of this function right here? Read. Positive 5 and negative 1. Positive and negative. Can you see a positive 5 and a negative 1 hidden in there at all? It's the opposite side. You learned this trick probably last year as well, that when you factored, you could find the roots. You were really asking what makes each bracket work out to 0. If it's factored, you can spot the roots. What's the roots of this one here? What's the x-intercept of this one here? I bet you it's 2. See it? See it, Brianna? What will the x-intercepts of this graph be? Negative, positive, let's double check. Negative 1, positive 5. There you go. So back to here. If you have an equation in factored form, you know the roots, you know the x-intercepts. This equation has has 2 x-intercepts, negative 1 and positive 5. How many factors does this equation have? 2. How many factors does this equation have? 3, but that negative 2 does not give us any extra roots. This equation also has 2 x-intercepts at negative 1 and positive 5. This one, when we factored it, ended up becoming that. It has 1 x-intercept, often called a double root because it kisses right there. What's the x-intercept at? 2, or 2, 0. So, here's a great question. I could give you a polynomial in factored form, and I could say, hey, tell me the roots, tell me the zeros. What are the zeros of function p? Will that 7 give you a 0? The 7 in front, does that give you a root at all? No. What's the root of that factor? What's the x-intercept of that factor? 1. What's the x-intercept of that factor? Negative 6. Very quickly, if you don't believe me, I'll prove it to you. I'm going to graph it really, really quickly. You can graph it quick if you want, but I'm going to type it faster than most of you can. There's the function. I'm going to go zoom standard, draw. Now, the vertex is clearly down here somewhere, and I don't care. I'm going to go G-solve, find the roots. Where's the first one? Negative 6. arrow sideways. Where's the second one? 1. Those that have the older black calculators, it'll take a lot longer because it actually moves the dot along, which is cool to watch, but they clued in. It really slows things down, although it's cool to watch, so they stopped doing that. But there's your roots. Okay. What are the roots of function q? What are the roots of this one here? Which way does this function open, up or down? Down. With only one root, I can tell you that this graph here sits at -3, and I bet you that's the vertex. That's the only way I can get one root, is if I kiss. And I know it opens down. So it says complete the table. Oh, here we go. Direction of opening, P of x, which way does it open? Up, how do you know? The leading coefficient is positive. Okay? Up. Q of x, which way does it open? Down. How do I know? Leading coefficient is negative. How many x-intercepts? How many different factors with x's in them? 2. What if we had 3 factors with x's in them? How many x-intercepts would there be? 3. What if we had 4 factors with x's in them? How many x-intercepts would there be? 4. Okay. 1 x-intercept for q of x. The value, 1, 0, and -6, 0, -3, 0. Right? I'll write it as a point this time. Value of the y-intercept. Put your pencils down. Rachel, do you remember how we found the y-intercept? I picked on you back here. How did you know that the y-intercept of function k was 10? How did you know that the y-intercept of function f was -5? How did you know that the y-intercept of function g was 10? What was it? But what told you? There's an expression I'm looking for. Begins with the letter C. Anybody remember? The constant term. Okay? What tells you the y-intercept? The constant term. What, nice and loud, what tells you the y-intercept? The? Okay, you ready? See this guy here? What would the constant term be? Keep your pencils down for a second. Just watch. Well, remember FOIL? First, outside, remember all that stuff? Here's what I know. Somewhere along the way, I'd be multiplying those two guys together. Yes? What is -1 times +6? That's my constant term. Oh, wait. What's in the very front there? You know what the constant term of this is going to be? It's going to be, that's the fast way where you can actually do this in your head. It's knowing that when I FOIL, the constant term always comes from the two numbers multiplied, although I should multiply it also, Taylor, onto anything that's in the front. Now, prove it, Mr. Dueck. Okay. Ready? G solve. Hey, what's this stand for? -42. Ding, 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 ding. If I had already typed the equation in, I'd use my graphing calculator, but I'm lazy, Jake. If I can just clue in that it's going to be the constant terms multiplied together times the coefficient in front, that's going to be the constant term. In other words, here, the constant term is going to be 3 squared, which is what? Times negative. Help me out. I guarantee that's the y-intercept. Now, Rachel, before you turn the page, come back here, pick your pencils up. How did you say we could find the y-intercept? Your first explanation, you said let x be. So you know what? Really what I'm doing is I'm putting a 0 there and a 0 there. And it's really 7 times -1 times +6. It's really 0 plus 3, which is squared, 9, negative. Okay? Putting in a 0 for the x. That's why that shortcut works. Now turn the page. New concept. This is brand new. We want to talk about the end behavior. What we mean by that, Ashley, is how does the graph behave as it exits the screen? I know here in the middle there's weird stuff happening. How does the graph behave as it exits the screen, as it gets towards its ends? What's its end behavior? So the end behavior of a graph, of a polynomial function, describes the appearance of the graph at the left end and at the right tail. Left tail and right tail, the ends, as it expands. Okay. So for degree 0, which was the constant function, a horizontal line, each tail just remains at its constant value. From left to right, the line goes that way. Meh. Degree 1, linear function which fits y equals mx plus b. The end behavior is determined by the leading coefficient. It says, complete the following, inserting the word up or down in each blank space. If the leading coefficient is positive, if that number right there is positive, then the right side of the graph, the right tail of the graph, this portion goes up, and the left tail goes, and we call that a positive slope. But I'm giving you a slightly different way to think about it. If the leading coefficient is negative, then the right tail of the graph goes down. Left tail of the graph goes up. What about for degree 2, the quadratic, the parabola? Well, that's also determined by the leading coefficient, by the sign of the leading coefficient. If the leading coefficient is positive, like that, then the right tail of the graph goes up or down? Up. And the left tail of the graph goes up or down? Don't overcomplicate it. Up or down? Up. Last year, Brianna, you called that opens up. But now I'm saying, don't talk about the opening. Talk about what's going on with the pointy parts. Oh, they're continuing to go up. What if the leading coefficient is negative? Down. Okay. So let's put it all together. It says complete the table using the word up or down to describe the end behavior of the graph of each function. And then use the word maximum, minimum, or none to describe the nature of the turning point. Let's don't cross this out. We're going to do that last. Don't cross it out. We're just going to do it last. What kind of a graph is this? Constant, linear, or quadratic? Degree 0, 1, or 2? Okay, I'm going to make a little note here. Degree equals 1. That would be a good test question. So, what does that look like? Well, another nickname for a degree 1 graph is linear. It's a line sloping which way? Sloping up or sloping down? How do you know? Okay, so I'm going to make a little note right here, quick sketch. I'm going to say it looks like that. Maybe different, but it looks like that. So, what can you tell me about the left-hand tail, pointing up or pointing down? How about U for up? What would be a good letter to use for down? Hey, Captain Obvious. What about the right tail? Down? We'll do the turning point last. Let's do the next one. G. What's the degree of function G? Ooh, that's a quadratic. Or what did we name that graph? Parabola. Opening which way? How do I know? Okay, so if I was going to do that one as a sketch, something like that. By the way, what's the y-intercept of this graph? -7. You notice I was clever. I even gave myself a negative y-intercept when I sketched this. By the way, what's the y-intercept of this first graph? Positive. You'll notice I made sure I had a positive y-intercept. I'm trying to do at least a reasonably accurate sketch. Okay. Left tail pointing which way? Right tail pointing which way? Now again, the fancy word for that is left end behavior. Same question, same answer. Up. Same question, same answer. Right end behavior. Up. I'm not going to use the word tail on your test. It's going to be left end behavior, right end behavior. Graph H. What's that? What's the degree? Zero? Oh, they wrote the x second to try and confuse me. But yeah, degree 1, which means it's it's a linear. Positive or negative slope? Wait a minute, I see a -5. How can it be positive? Okay, the leading coefficient is the number in front of the x. They just mucked around with the order. I'm not going to let them fool me. So this is going to be a positive slope. What's the y-intercept of this thing? You know what? Oh, it looks something like that. So what can you tell me about the left end behavior? What about the right end behavior? Last one. What's the degree of this last one? Oh, quadratic. Oh, what shape is that then? Opening which way? How do you know? By the way, what would the y-intercept of this one be? 6. So probably looks something like that. You know what? I'm not sure. The vertex could be on the other side. I don't know. But I'm just telling you, I know the y-intercept is above 0. It looks something like that. What does the left end behavior do? Sorry? What about the right end behavior? How many roots? 2. Could you draw this with a y-intercept of 6 opening down and only have 1? I don't think so. Could you draw this with a y-intercept of 6 opening down and have none? Really? You can think it. None of it opens down. Could you draw it with a y-intercept of 6 opening up and possibly have none? Yeah. Okay, but there's lots of information. If I know the y-intercept and the shape, Giancarlo, there's lots of information. You awake?
Yeah, I'm struggling.
I know. That's why I picked on you. Okay.
Thank you.
What's the last column we're filling out? That means either it has a turning point that's a maximum, it has a turning point that's a minimum, or maybe it has no turning point at all. So we have none, max, or min. I can't use M as my abbreviation because min and max both begin with M, so I'll have to go max and min. Yeah. What does the R stand for? I don't know. You're right. I was thinking right. Down, is that what you're saying, Alyssa? Candy for you. Thank you. And now it spells dud, which was kind of that move that I just pulled off right now. Dud. Thank you. Dud. Yeah. Sorry. Hey, what's the nature of this graph's turning point? It's a trick question. Is none. What's the nature of this graph's turning point? Max, min, or none? Someone said max, someone said min, so someone's right. What? It's the lowest point, yes? What's another word for lowest? Minimum. Okay, so it's a min. What about here? None? What about here? Get your graphing calculators out, please. Go to your graph menu, clear any graphs that you have. Okay. Everybody have their graphing calculator here? Holy smokes. Okay. Let's type in k of x, which says 6, take away 2x, take away x squared. Now, I would like, and I'm going to, Kyle, answer these questions in this chart in my head, but I'll show you how if you freeze or you just want to check your answer using technology, you can. It's slower. It works. Go shift view window, go view standard if you haven't already. What should this be a graph of? What did we say? Parabola opening which way? So hit draw. Oh, nice. Certainly I can see the end behavior down and down. What else could you find? Hit G solve. Okay. Find the roots, the x-intercepts. Hit F1. I didn't try and make this work out evenly. 3.6. How do I find the second root? How do I move over? Okay, right arrow will do it. And again, the older black calculators will take a while, but it is kind of cool. You see the dot moving, and there is a, you know, it's animated. Yeah. You got those same roots? Okay. What else can I find? Hit G solve. The vertex, is it a maximum or a minimum? Well, then hit F2. And lo and behold, I just found the vertex. You also learned how to do this on your own last year by hand using what was called completing the square. And it was probably one of the single toughest lessons of all of Foundations of Math 11. I know it used to be in the old Principles of Math 11 course, and it was tied for my second toughest lesson of the year. The only one tougher was optimization problems, which were word problems that required you to complete the square. I'm going to pause because I see people typing. Are we there? Okay. Pause for a second. G solve. Is there a minimum of this graph? So try it, see what happens if you accidentally hit the wrong thing. Okay? Get an error. Oh, how do I get out of an error? Does yours also say press exit when you hit minimum? Yep. Yeah, it's gonna look for a while. Okay. So press exit. Draw. What else can we find? Everything's under G solve. Oh, the y-intercept, which I already told you was 6. Try finding the y-intercept, please. Ta-da. What happened?
No.
Hit the wrong thing?
No, that's good. I'm good.
We're good? G solve. All right. What does this one stand for? What do you think ISCT stands for? It stands for intersection. And what it asks is where two graphs cross. How many graphs have we done? Okay, we'll come back to that then, because right now, I think if you hit it, you're going to get an error of some type. It doesn't do anything. It's saying, I can't find where two graphs cross. Captain Obvious, you've only given me one graph. Okay, I'm going to pause. We're there? Yeah, yeah? Okay. Hey, arrow sideways, please. Have we already done y-cal? Yes. Have we already done x-cal? Yep. Okay, what's that next thing? Hey, let's hit it and find out. It's called an integral. Yep. Arrow sideways. F6. Okay, hang on. To be completely honest, I've never hit this button either yet. No, it does not. What's this word here? Lower. It's actually saying, what's the lower value you want me to start out at? I'm going to say, let's start out at, oh, you know what? I think I can type 1. And a little line appears. Okay. I just typed 1. Now, black calculators, I'm not sure that'll work. I'll come back to you guys in a second. Okay? Then it wants an upper value. How about 2? And believe it or not, I don't know if you could, yeah. This is how you find the area under a curve. Those that are in my physics class may recall when we did gravitational potential energy, it was a curve, and I said we can't get there because it requires us to find the area under a curve. This is taking an integral. You actually can do it by hand as well. The calculus students will be starting that in the next couple of weeks. You will not need to know that, but since I'd showed you every other function, how could I resist showing you that? What's your homework? Number 1. 2. 3 is good. 4 is good. 5 is good. Now 5 says use a graphing calculator. If you can do it in your head and visualize the graph, that's more gooder. That's better. You're good. Glad you caught that. Number 6 says complete without using graphing technology if you can. If you need to bail out and use the technology, I've showed you how to use the technology. What's faster, in your head or technology? Still in our heads by a long shot. 7 is good. 8 is good. So all of it. You got lots of time. Also, if you have any homework from the past unit that you want to show me, now is the time.